All right, this video, as you can see, is entitled Free Fall Motion. So, of course, we're talking about free fall motion. Free fall motion is motion of an object that is being acted upon solely by gravity. So in this case, when we drop something off a building, or you jump off a building, or something is falling from the sky, it's really being acted upon by gravity only, and therefore we call that free fall motion. There's two kinds of problems we'll solve. One is we know the time, and we want to know the height of the object, the time for it to fall. The other one is we know the height of the building, or the height the object is falling, and we want to know how long, the time. And of course, these are the equations that we'll use. These are our kinematic equations. All right, so let's go. It's really good to write down what we know. So what do we know about the problem? We can get all this stuff out of the problem, and therefore we'll know everything that we know, and we write it down, and we know that the time is 3.85 seconds. Now, there are a couple other things we know that aren't actually stated explicitly in the problem. We know one thing about one of the velocities. We don't know the final velocity, but we do know the initial velocity because it's being dropped, and it doesn't say it, but the initial velocity is 0 meters per second. Think about what you do. You hold something, you drop it, the initial velocity is 0 meters per second. And the other thing we know for sure, because we live here on Earth, not on the moon, that the acceleration is 10 meters per second squared. And of course, because it's falling down, and we consider down in the y direction negative, we're going to put negative 10 meters per second squared. Okay, so now what equation are we going to use? We know the time, we know the initial, and we know the acceleration. So we want to know the distance. This doesn't have distances, so we can't really use that equation. This one, we need the final velocity, which we don't have. And this one here, we know the initial, we know the time, we know the acceleration, time, all that kind of stuff, so we can use number 3. So let's go ahead and use the third equation. It works out pretty well, as you'll see. Now I'm going to put down here y, because that is the direction that we're going in, and we know that the equation is VIT plus 1/2 AT squared. Okay, now let's look very carefully at what we know, and it looks a little complicated, but we know here that the initial velocity is 0, and VI times t is 0 times any number, or 0 times the time, and that means that this whole thing is going to go to be 0. So now we have that y equals 1/2 AT squared. All right, so here we are, 1/2 AT squared, and we can just plug the numbers in and solve now. So we know that, let's do that right over here, we have 1/2, and we have minus 10 meters per second, and we have our time. I'm going to put this in parentheses because we're going to square our time and our units. So I'm going to put 3.85 seconds squared, and if we solve all of that for y, you can see that this is squared down here, and this squareds are going to cancel, and this second squared is going to cancel, and we're left with y being, that is the distance, and you'll know we have a negative number here, so we have a negative 74 meters. Okay, so that's the answer to the distance. The distance is negative 74 meters. Now, what does that mean, negative 74 meters? It just means you're falling in the negative direction. Okay, and this is the negative direction. Now let's just do the final velocity really quickly. Okay, we can use the first equation. Final velocity is the initial velocity plus AT. Now, once again, we know that the initial velocity is 0, so that the velocity final is just going to be AT. And we've kind of talked about this before, and that means that the acceleration is minus 10 meters per second squared. And we know that we're going to be accelerating for 3.85 seconds, and therefore this second is going to cancel with one of these seconds, and we're going to end up with the final velocity being 38.5 meters per second. It's just the time times the acceleration. Okay, so that's the answer to number 1. In this case, it's minus 74 meters, and it's 38.5 meters per second. All right, let's try and go on and do the second one. Okay, the second one is very similar, except in this case, now we know that the height, and I'm going to put the dimension, the y direction, is 9.75 meters. Now once again, we know the initial velocity is 0 meters per second. We know the acceleration is minus 10 meters second squared. Okay, and we want to know the time. Okay, now this one, the math or the algebra is a little more complicated, but in this case, we know that we're going to use, let's see, the same equation. Okay, we want to know the height. We don't know the final velocity. This equation doesn't have the height in it or the distance in it. This one does, and we can use the same equation, so we'll use the same equation again. We're just going to solve it a little differently. Okay, so I'm going to put down here that y, which we know, equals VIT plus 1/2 AT squared. And once again, the initial velocity is 0. And that means that y equals 1/2 AT squared. Now, we already know y, so we don't want to solve for y. We actually want to solve for t. Now, I'm not going to go through all the algebra in this video here, but as we've talked about before, and as you could solve this, it's relatively easy to solve. T would equal the square root of, we put 2y over a. And you got to do all that stuff first and then take the square root of it. And so we could put in here that it's 2 times minus 9.75 meters, because it's falling in the negative direction, over the acceleration, which is minus 10 meters per second squared. Okay, we can draw this down here a little bit. And in this case, we get that the time equals 1.40 seconds. Okay, that's the time. You can see we have meters here. This cancels with this. When we take the square root of second squared, we get seconds, and therefore that's our answer. Okay, so the time is 1.40 seconds. Now, the final velocity, once again, is the VI plus AT, and we know that once again VI goes to 0, or is 0. That means it's just once again the acceleration, which is minus 10 meters per second squared times 1.40 seconds, and we get this seconds cancels with one of these, and the answer in this case is minus 14.0 meters per second. And once again, it's minus because it's coming down, it's falling down, it's going in the negative direction. Okay, so hopefully that helps you out. Those two are the most common types of problems I think you'll come in contact with when it's an object just falling down. All right, thank you.